2015 Leaving Cert Ordinary Level, Paper 2, Question 1. So this one starts off by saying a bank issues a unique 6-digit password to each of its online customers. The password may contain any of the numbers 0 to 9 in any position, and numbers may be repeated. For example, the following is a valid password. Okay, so we can see that, the digits can be in any order and they can be repeated. So its first bit is asking us how many different passwords are possible. So there's sort of two ways you can do this. You can do it using the number of choices you have, right? So in each, I'm just going to draw a series of 6 boxes here. I'm going to ask myself, how many choices have I got for each box? How many choice of digits can I pick? So for the first box, I can pick any of the digits from 0 to 9. That's not 9 digits, it's 10 digits. So I've got 10 choices for that. So in place of that, I'm going to put 10. For the second box, because I can repeat digits, I've again got 10 choices for this box. And the same for the next box. And all the way along, I've got 10 choices for each box. Now for each of the 10 choices I have there, I've got 10 here. So we're going to multiply those. 10 by 10 is 100. So for every one of those 100 choices I have for those two first positions, I've got 10 here. So again, you're going to multiply all the way along. So you've got 6 tens multiplied by each other, which is the same thing as 10 to the power of 6, which in everyday language would be 1 million. So there are 1 million passwords. Obviously, the more digits you have here, the more possible passwords there are. Okay, even adding one more digit would make the possible number 10 million, 10 times greater. But it's not the only way to do this question. Another way to do it would be to say, actually count the number if you like. So the lowest possible number that I could have for my password would be all zeros. So I could go from having all zeros, then I could make the next password 000-001, make the next one 000-002, and so on. I could do that all the way up to 999,999. Now if you count the number of numbers from that number to that number inclusive, you're going to get 1 million. That's another way of doing it. But obviously only give one way of doing it, don't do 2 different ways. But it's always helpful to know 2 different ways of doing a question. That's part A done. Now, then it says, how many different passwords do not contain any 0? This is why it's advantageous to do it this way here, the previous one, because to do this part of the question this way would be very difficult, because throughout these numbers here there are zeros everywhere. So let's do this the number of choices way again. So I want none of my passwords to have a 0 in it. Again, I'm going to ask myself, well, how many choices have I got for each box? Now, for the first box, I don't have 10 choices anymore. I've got 9 choices because I'm not allowed to pick 0, but I can pick any other number. So I've got 9 choices for that. Again, because digits can be repeated, as long as I don't have 0, I can do that. So I'm going to have, again, 9 choices for this. 9 choices for every single one. And again here, what you're going to do is you're going to multiply. So for that, that's like 9 to the power of 6, which we'll just see what we get on the calculator here. So 9 to the 6 is 531,441. So it's almost halved, even without allowing 0 to be used. You've almost halved the number of possible passwords. Then it says here, one password is selected at random from all the possible passwords. What is the probability that this password contains at least one zero? Now, okay, so when you were asked for probability, I always say that probability takes thinking. It doesn't matter how experienced you are with it, you do have to think through every individual question that you're doing. So what is the probability that this password contains at least one zero? So, okay, so it's going to add in something here. So the probability that the password contains at least 1 0 is going to equal, let's bring this down here, I should say 0 of course, is going to equal the number of passwords that contain 1 0 divided by the total number of possible passwords. Now, before we go anywhere, that has got to make sense. If I want to find out the probability that a password that I select at random contains at least 1 0, I've got to know how many passwords contain at least, I should say at least of course there, at least 1 0 divided by the total number of passwords. Now, you think about it, a password that I select at random is either going to contain at least 1 0 or no zeros at all. This here is a number of passwords that do not contain any zeros at all. All the rest of them will contain at least 1 0. So the number of passwords that contain at least 1 0 is going to be the difference between the number that don't contain any zero and the total number possible. So it's going to be 1 million. Take away the number that do not contain any zeros whatsoever, so 531,441. Divided by the total number, which is just 1 million. So let's see what that is. So yeah, you're going to get this as a decimal. So it doesn't specify how many decimal points they want you to go to, decimal places they want you to go to. So I'll just put in all of them here. So it's about approximately 0.7. So it's about a 47% chance that the password you set at random contains at least 1 0. Okay. Then finally here it says, John is issued with one such password from the bank. And when it says one such password, it's talking about those that contain at least 1 0. So each time John wants to access his account online, the bank's website requires him to input 3 of his password digits into the boxes provided. For example, he may be asked for the 2nd, 4th, and 5th digits as shown. In how many different ways can the bank select the 3 required boxes? Okay, so he could be asked for the 1st, 2nd, and 3rd. He could be asked for the 1st, 3rd, and 4th. He could be asked for the 2nd, 4th, and 5th. He could be asked for the whatever. Now, to do this, we're going to use what we call combinations. I think the best way to think of this is, imagine you had 6 people on a bench. I'll just call them first, second, third, fourth, fifth, and sixth. You can imagine them as the first, or the oldest, the second oldest, the third oldest, and so on, just to distinguish them. And I'm going to select 3 of them for team. Team could be whatever team. And I want to know the number of unique trios that I can pick. So I pick the first 3 there, and then I pick them in the order second, third, and first. It's still the same team. If I pick them first, second, and third, and then select them second, third, and first, or third, second, and first, it's all the same team. So they don't count as individual teams. So if you're selecting, the number of objects you're selecting from is 6, and you want to select 3 of them in any order, the number of ways you can do that is what we call 6 choose 3, or 6C3. Okay, so you can do this in the calculator by typing this button here, NPR. Now, if you're using the Casio calculator with the 2 orange buttons, you want to press Shift and the, sorry, not, that should say NCR, of course, not NPR. It's the NCR is above the divide button. You need to press Shift and that button there. But if you're doing this on paper, what you could do is you could do 6 by 5 by 4, or for 3 by 2 by 1. So that's going to give you then 20. So there are 20 different ways the banks can select those 3 required boxes. And that is question 1 completed.